Hello everybody. Today I'm going to be refining 925 sterling silver scrap into 5/9 purity. In this batch I will be refining 1011 grams of scrap sterling silver. Most of this batch contains the remnants of candlesticks, some silverware, and a teapot. It's a good idea to have a good mixture of scrap, as the thinner scrap will dissolve much more quickly than the thicker scrap. Most sterling silver will be clearly labeled with a sterling mark and some numbers, but if you are unsure, it is a good idea to test using silver test solution. Just apply 1 drop to your suspected silver and allow 30 seconds for it to react. What's happening here is the silver testing solution is made up of a dichromate salt that has been dissolved in nitric acid. As the nitric acid reacts with the silver, it produces silver nitrate. The silver nitrate then reacts with the dichromate salt to produce silver dichromate crystals, which are crimson in color. As a comparison, a lack of silver in solution will cause the dichromate salt to oxidize upon evaporation and turn clear. After mechanically cleaning the sterling silver of all non-silver material, especially iron supports or reinforcements, I will incinerate the items to remove any oil or wax that might be present. It is important to heat everything to redness to ensure proper removal of debris. I will be using a large scientific glass container set inside a glass dish. I will only be using distilled water throughout the refining process. Any other water, including purified, will contain trace amounts of chlorine. If any chlorine or chloride gets into the reaction, it will produce silver chloride that is insoluble in nitric acid, and it will gum up the filter, also making it more difficult to process the filters at a later date. We will start with 1 liter of distilled water. I will be dissolving the silver with nitric acid that I distilled in a previous video. This nitric acid is of a much higher concentration than the store-bought nitric acid. It generally takes around 800 milliliters of nitric acid that I produce to dissolve 1,000 grams of sterling silver. I will add the nitric acid in small increments, doses of around 200 milliliters at a time. I would not recommend adding all your acid in one dose, as the reaction may boil out of control. Be sure to cover the container. As the water boils, it will create steam, and that steam will combine with the nitrogen dioxide gas, creating a weak nitric acid solution that will rain back down into our refining operation. Be aware, this experiment produces copious amounts of nitrogen dioxide gas and should be performed only in a fume hood or outside. As the nitric acid dissolves the sterling silver, the solution will turn blue. That is the color of copper in a +2 oxidation stage. As more silver is consumed, the reaction will slow down. Now that the reaction has settled down, we will add more nitric acid and silver. Add the nitric acid slowly and then wait a minute to be sure that the solution remains calm. Although this reaction generates a lot of heat, I would recommend keeping your hot plate at a medium heat in order to drive the reaction forward as quickly as possible. It is now safe to add more silver. I started the batch with a big chunk of silver in the form of a teapot. That was about 1/3 of my batch. Now I will add all the thin pieces of silver. The thin pieces will dissolve very quickly. If at any point in time during the reaction it looks as though it might boil over, don't panic. Simply add a small amount of room temperature distilled water, and that will stall the reaction. Now that we are halfway through our batch of silver, we will add 500 milliliters of distilled water in order to dilute the solution and allow more room for metals to be dissolved safely. another small addition of nitric acid. Once you are sure the solution is calm, add more silver. This is the last of the thin pieces of silver. This is the last dose of nitric acid that I will be adding, and it is to ensure that all the small pieces of silver have been dissolved. Now I will add the last few pieces of chunky silver from my batch. The reason I held the chunky pieces back was because I wanted to make sure all the small silver particulate had been dissolved. It's easier to pick big chunks out that have not been reacted than it is to remove fine particulate. Here is an example of where the nitrogen dioxide combined with the steam to produce nitric acid. It looks as though I have overshot the amount of acid that was required to dissolve this batch. All of the sterling silver has been dissolved, and there is still a small amount of free nitric acid present. It is important to use up all the remaining nitric acid in this solution. If we don't use up all the nitric acid, when we go to precipitate the silver out of solution with copper, it will just dissolve the copper and may cause the silver that does precipitate out of solution to foam and float to the top. I will use a nice chunky piece of silver from my next batch to use up all the remaining nitric acid. This should be enough to consume the last of the acid. Once all the nitric acid has been used up, there will be no orange nitrogen dioxide fumes. Also, there will be no reaction between the silver and the simmering hot nitric solution. Turn the heat off and allow the solution to cool to room temperature. Once the solution has cooled, we will set up for a vacuum filtration. I am using a large Buchner funnel and a fine filter paper. Using distilled water, we will siphon the nitric solution into the funnel, leaving the sediment for last as to ensure a quick filtration. Having a very large filter area really comes in handy. There seems to be some metallic foil that didn't dissolve in the nitric acid. I can only assume that this is gold or some platinum group metal. The filter will mostly contain cement and wax residue. A small percentage will be gold. I'm not sure what that foil is, but there seems to be a good amount of it. I wonder if someone had repaired a candlestick with platinum dental foil. If anyone knows what this is, please leave me a comment. Once the solution has been filtered, rinse the container and filter with distilled water till it runs clear. Transfer the nitric solution back to a clean container. Rinse the filter flask with distilled water. The solution should be free of all debris before precipitating the silver to ensure maximum purity. We will be using copper to displace the silver from solution. Copper will displace silver at a ratio of about 4:1, so we need around 275 grams of copper to displace 1100 grams of silver. I would recommend using an excess as to prevent the copper from splintering as it degrades. As soon as the copper touches the nitrate solution, it immediately starts displacing silver. What's happening here? The silver ions are attracting the copper electrons. As the copper electrons are ripped from the copper wire, the copper dissolves into the nitric solution. As the silver gains an electron, it precipitates out of the solution as a metallic crystal. As the metallics trade place in solution, a small amount of heat will be generated. Be sure to agitate the solution multiple times so as to expose more surface area to the silver nitrate. You'll know the reaction is complete when silver stops depositing on the copper wire. Remove the copper and clean it with distilled water. Add the coil wash water to your silver. Once the solution has settled, siphon off the copper nitrate using distilled water and save the waste for further processing at a later date. Remember, don't pour the solution. Slowly siphon for best results. Now we will rinse and drain 3 times with distilled water. The reason we are using distilled water for the first 3 rinses is to ensure that if any silver nitrate remains, it will not be converted into silver chloride as it comes into contact with tap water. After rinsing 3 times with the distilled water, and an additional 4 times with tap water. The solution should be clear. Siphon off the remaining liquid. The tap water rinses are safe to go down the drain. Transfer your silver powder to a stainless steel pot for quick drying on the stove. Simmer on a low heat to prevent splattering. You'll know the silver is completely dry when it stops fuming. Okay, let's get a final weight. This is the piece of silver that I used to consume the last of the free nitric acid. It originally weighed 220 grams. It looks as though 88 grams of silver was dissolved from it. I started with 1,011 grams. I added an extra 88 grams, making the total 1,099 grams, with a return of 998 grams. So that puts the percentage of silver from this batch at 91%, very close to the suspected 92.5% in sterling silver, although I did not tally up the weight of the filtered material. Thank you for watching. If you enjoyed this video, please like and subscribe.